Hi everyone, we can go for the another question in the clutch section. It is not a problem, it is a derivation, so just listen. A single dry plate clutch has a diameter dO which is fixed due to space limitation. The permissible pressure intensity is P and the coefficient of friction is F, or we can write it as mu, coefficient of friction. Then show that the torque transmitting capacity of the clutch is maximum when dI by dO is equal to 0.577. So it is a condition. They are given that one condition, that is dI by dO is equal to 0.577. So we can just go to the solution. We know that this is general question and the theory is not explained. So we can take the general as a uniform wire theory. In a uniform wire theory, T is equal to half into mu into F A W into dMW. Where is that equation? That is equation in our data book, page number 258, equation number 13.9 E. Then again the axial load, what is FAW? FAW is equal to half into pi into P max into dI into dO minus dI. Where is that equation? That is equation is also in our data book, page number 258, equation number 13.90. Then we need one more thing, that is dm. Here in this equation, Fi we already write in terms of di and do, and one more thing, dm. Dm is equal to do plus di divided by 2. That is also in our data book, page number 259. So just go through the data books and familiarize these equations. Now we can write the torque equation. T is equal to half into mu into pi by 2 into P into di into do minus di into do plus di. And we can convert this equation into this one. We can take it as a minus b into a plus b, that is equal to a square minus b square. So compare that equation with here, then we can write pi by pi p into f, or coefficient of friction mu, divided by 8 into do square minus di square into di. Then in our question the value is given as a ratio, that is di by do. So to go for that solution, we can take do outside, do square outside. Then that equation will convert into 1 minus di square by do square. Or for the easiness, we can write as a single value, or it is written as di by do is equal to y. Then here it is di by do, that is y into do minus into 1 minus y square, or we can write y minus y cube. This 3 is not outside, just y minus y cube. Now for the optimum torque capacity or the maximum torque capacity, we can write, or we can differentiate this value. If that value is 0, we will get the optimum solution, that is dt by dy is equal to 0. Or we can write here the variable is only y minus y cube is equal to 0. If we differentiate this one, we will get y minus 1 minus 3 into y square is equal to 0, or 3y square is equal to 1, or we can write y is equal to 1 divided by root 3. What is that value? 1 divided by root 3, that is equal to 0.577. So y max, what is y? Y is equal to di by do, that is di by do is equal to 0.577. That is our question. Okay, thank you. We can continue one more question. It is for the multiple plate clutch. Just listen to the question. A multiple disc clutch is composed of 5 steel and 4 bronze discs. So the number of discs is shown as 5 steel and 4. So total 5 plus 4. Okay. The clutch is required to transmit maximum torque of 240 Newton meter. The torque is given as 240. Then assume a factor of safety is 2.5 for slippage and full engine torque. If P is equal to 0.35 megapascal, the maximum pressure is given is 0.35 megapascal and coefficient of friction is 0.25. Calculate the diameter of the friction lining. They are asking about the friction lining. How we can calculate? First of all, we can write the given data. The value of number of plates, it is first plate we can denote it as N1, that is equal to 5, and second section we can denote it as N2, that is equal to 4. Then what is the value of torque? Torque is equal to 240 Newton meter. It is actually not 240 because the factor of safety is given, so we have to convert it into factor of safety value that we can explain, that I can explain later. Then the pressure is given as 0.35, then the friction is given as 0.25, then find the value of dA dO. So listen for the answer. Frictional torque Tf, we can denote as Tf is equal to T into F. What is the value? T into beta. What is beta? Beta is the factor of safety. We can write that value. Here it is 240 into 10 raised to 3 into 2.5. That will become 6 into 10 raised to 5 Newton millimeter. That is the value of torque, frictional torque. And from the data book, we can write this equation T is equal to half into mu into FAW into DMW into N dash. Page number 259, equation number 13.9F. So we can use this equation, and now we can go for the FA value. What is that FA value? FA value is also in the data book, page number 258. Half into pi into P di into do minus da. If we substitute the value of P here, we can convert that equation, that is FA in terms of da and do. We will get that equation. Then next one is the dm value, but here do and di are not given. That is the that is the value they are asking. Now we can go for the n dash value. How we can find the n dash value? It is a one condition. N dash we can take like this, that is n1 plus n2 minus 1. That is the number of contacting surfaces we can find using this equation also. Here it will become 8. Now for the general solution, we can write 6 into 10 raised to 5, that is the value of T, that is equal to 0.25 into 8 divided by 2 into this value, that is all values we will get in terms of di and do. Now we can solve that value into the terms of di and do, then equation will become like this: 2.18 into 10 raised to 6 equal to do square minus di square into da. Then now we can go for the previous problem, that is I can read this section. Since there are two unknowns and we have only one equation, so problem cannot be solved. So we can go for a assumption. What is that assumption? di by do is equal to 0.577. That is the assumption we can take from the previous question that we already stated, or we shown how that will become. So di by do is equal to 0.5, and if we substitute this value here, then we can find the value of do. Once if we find the value of do, then we can calculate the value of di also. Okay, thank you.